Wow, what an audience. Okay, I want to start with a question here. How many people in the room, let's see a show of hands, actually use Java? Okay, over 2,000 people here, I think, today, and the amazing thing to me is that this is a very small fraction. Notice I started to say percent, but he scared me, so I'm going to say a very small fraction of the estimated 9 million Java developers in the world. What a force. This is amazing. So it's a great honor to be here in this beautiful city. This is my contact information. I'll repeat that at the end. But our topic this morning in my talk is to look at the future and how the future has arrived here, what's really working and what's worth taking advantage of. So let's start with the question about the future. What did the future look like previously? What did we think the future would be? Well, things don't always turn out the way people expected. When I was a kid, people said we would all be moving around in jetpacks by now. I know they do exist, but to tell you the truth, when I arrived here this weekend, I actually came in from the airport on this nice train, which I think was maybe a better choice given the weather. So not everything turns out the way we predict, but some things do. Also, when I was a kid, there was a TV series called Star Trek. People may have heard of that. Remember, everybody went around, they had a communicator badge on their uniform, and that's the way they got data, they communicated, and it turns out that has actually happened today. It just didn't look the way we expected it to. And to tell you the truth, when mobile phones looked like this, I think people had to have real vision to imagine they were ever going to be that kind of central data device that dominates everybody's lives today. And so the future shows up in different ways. Sometimes it works out the way we think. Sometimes it works out the way we expected, and yet through a different mechanism. But the question is, which bits of the future, which have arrived already now, are worth embracing and are going to make a big difference in the work that you do? William Gibson, a science fiction writer, says the future is already here. It's just not evenly distributed. And so with that thought in mind, how can you best take advantage of the bits that are going to make a big difference for you? Another way to put it is, how will you stand out in your field in the things that you do? Now, the fact that we're here in Stockholm immediately made me think about the Nobel Academy and Nobel Prize. As Matthias said, I used to be a biochemist, molecular biologist. Through that work, and also through just accidental encounters, I've actually had the fun to meet about a dozen different Nobel laureates in vastly different fields. Some of them were the unusual ones. Our ex-president Barack Obama. Probably the oddest encounter is with a man named Greg Flato, whom I met on a summer horseback trip up in the Canadian Rockies. He was on his vacation and helping his brother out, so he was actually leading this pack of tourists up into the mountains. And it was only in a lunch break that we also found out he was one of the authors on the IPCC report, which received a Nobel Prize relative to climate change. But most of the people that I got to know were in the field of chemistry, medicine, molecular biology. And for today, I just want to call your attention to one person. I didn't know him. I knew somebody else who shared the prize. This 1980 prize, which had to do with early understanding of how to sequence and clone DNA. I actually did know Paul Berg, but that's not who I want to tell you about. The man in the middle, Wally Gilbert, I never met, but I found his story interesting for the following reason. He actually started off as a physicist, and he took that experience and knowledge into the field of chemistry, fairly traditional chemistry, and made some amazing discoveries and advances. And then, because his wife was working with Watson, he got interested in the early days of molecular biology and in DNA. And so he took his knowledge of chemistry into that field and worked out a chemical basis for doing DNA sequencing, and that was the basis for this prize. So the lesson here that applies to you is that really exciting things can happen when two different knowledge bases, two different types of experience collide, especially in fields that are undergoing a lot of flux, a lot of change, and I think that's very much true for the way people work with data today. And so we have this room full of people with enormous skills in terms of programming and development. There are new ways of working coming in collision with this, including big data. And I think this really opens some incredible opportunities to see what you'll actually build with that. And so with that in mind, the themes that I want to touch on today are big data, how people work with data and how that's changing. Keep in mind changes not just in volume, but also in speed, the importance of flexibility, and just touch for a moment on a special topic, which is machine learning and AI. Now let's start with data, and I want to start with a big data success story. And what's unusual about this story, or a little surprising, is that this actually took place in the 19th century. An officer in the U.S. Navy, Matthew Morey, injured himself. He could no longer go to sea. You'd think that's where the excitement ends, but it's really where his life got exciting. Even though he had a desk job, he noticed that there were boxes and boxes filled with logs, these old discarded books that were the accounts of individual voyages. Each one had very little value unless it was something specific of interest in that voyage. But Morey recognized that with his team and an excruciating amount of work, they could extract a huge amount of data relative to winds and currents from all of those different voyages. And with that, they produced an amazing new technology, their winds and currents charts, that could be used for much more efficient navigation. This really, literally was a life and death issue for people who were taking long sea voyages, and it also made a lot of people rich if they used it well. And so there was huge potential here. And what happened when he published these charts initially was basically nothing, because people weren't interested. They didn't recognize, they didn't have the vision to see how to use this. They hadn't had that wonderful collision of different experience yet. That is until one particular sea captain, Captain Jackson, took a trip from the east coast of the U.S., from Baltimore down to South America and back. He used these charts for navigation and actually shaved a month off of that trip. When you come back a month early, people notice now everybody wanted one. This turned into a real success story. But the lesson I want you to take from this is that data, big data, and this was large-scale data, is not just bigger than other data. It's different. It's qualitatively different. You can ask and answer questions that literally you couldn't ask before. And that, as people begin to recognize that, is really changing how they work with data now. But in order to do that, you don't have just the vision to ask the question, but you need new technologies to make this feasible. Now, big data has been around 10 years, this term. It's kind of a specialized thing. Some organizations would bring in a team to work with big data. It was kind of something set aside. But one thing that's really changed now is it's just become ubiquitous. It really has just become something that people work with. And in fact, there now is beginning to be a new word for big data, a new term, and that term is data. So this is just becoming the way that people work, but keep in mind, at scale, you really can ask different questions than you could have before. Now, another aspect of data is people are beginning to recognize the value of saving raw data where possible. Obviously, as you optimize data for use in a database, do preparation for machine learning and so forth, you're going to lose a lot of features. And it turns out those features might be of great value to other projects. And so if possible, if you can save that data so somebody else can come in and use it, that makes a big difference. And this is a real-world example, but an unusual one that shows that idea. Some medical labs in Canada actually froze blood samples for years, just on the off chance that there might be some valuable information in those samples later. And as it turns out, as genetic techniques developed, it became possible to ask questions about those samples that hadn't been possible before, and that combined with patient histories reveals some really important information about diseases. The key idea here is that this situation, this data had been preserved long before the analysis was being made. In fact, long before the analysis was even possible. Now, closer to the things that probably many of you work on, we see that kind of same situation. This is a hypothetical situation, but people doing fraud detection, for example, want to do that as quickly as possible. Maybe they have a model that detects that there's been some kind of breach or fraudulent event. You want to do that as soon as possible after the event to try to minimize loss. But what if you could ask an even better question? You could look for some sort of pattern, make a model that determined behavior at a point in time where you could actually prevent the fraudulent step. That would be even better. Even if you have that great idea and build a model, that only works if you had actually saved that data that previously you didn't know you're going to need. And so the fact is, data begins to have be recognized as having value kind of up on the par with code itself, sometimes needs to be considered and treated as production quality long before the code is completed or even begun to be written. Now, this is my reminder to shift and start to think about speed, but I just love this quote from the Danish poet Benny Andersen. He said, no matter how many clocks he has in the house, he never seems to have enough time. I certainly know how that feels. The world is changing, as I said, not just in the volume of data and the kinds of questions that are asked, but now there becomes a need to look at data and be able to process data for fast-moving events, and kind of in two different ways, to literally deal with fast data, with streaming data, event-by-event data, and to be able to process that with very low latency or with real-time guarantees. But a different kind of speed also in the kinds of queries that are written, how fast you can come up with the next query, how quickly can you interact with data, and that begins to happen in a rhythm that's almost like just a normal way for people to think. You don't have these long periods of time before you respond to how the world changes. And so there's a pressure to change the way people interact with data, and that puts a pressure on new technologies to be able to meet that need. I want to start off with calling your attention to a technology you're probably very aware of, Apache Flink. This is a highly scalable engine for processing streaming data. This is truly streaming. It's not micro-batching like the way Spark streaming works. It's truly stream analysis, but it can also be used for batch. Flink is actually bigger, better known here in Europe and in Asia than it is in the United States, although it's getting a lot of attention lately. The startup company Data Artisans, it's based in Berlin, was just purchased by Alibaba, so this has been in the news a lot. But I think Flink is an excellent technology. If you haven't used it, take a look at it. It's really responsive to developers, and it really handles a lot of things that have been very difficult to do in the past, and it does it elegantly. If you're curious, there isn't time to go into these use cases, but this is a link. You'll have these slides. This is a link for you to get videos and slides from the last Flink Forward conference, which was in San Francisco in the fall. There were presentations by companies like Netflix, eBay, Yelp, Alibaba, and how they're using Flink. But I just want to point out an idea that was expressed by the person who spoke from Yelp. And he said he had gone to a previous Flink Forward conference, and at that conference, he saw presentations that showed him so many different solutions where Flink could natively handle things that he and his team were having to build in at the application level. It isn't that there was no way to deal with these issues, but it was a lot of work to do it and very cumbersome. These are some issues that Flink can handle natively, and so he and his company began to move many different systems over to Flink. So I think there's a lesson there that goes beyond Flink is just a single technology and goes beyond looking at streaming data, and that's to increasingly pay attention to these new opportunities, new designs, and new technologies, but demand of them a way to handle stuff that you have to do across many different applications, make that more efficient by leveraging those technologies to handle that stuff natively, and that frees up your efforts to focus on the things that only you can do that are specific to the applications that you build. And this can make a big difference in the way that you work. It's not based on any single technology, but I think it's a way to embrace the future as it comes to you. I do want to point out one other example of the way people are using Flink. I happen to know of this one personally. A large financial institution had a core service. It was dealing with huge amounts of data that were coming in very fast. This core service is absolutely essential to their business. So they were actually using this data and just using and losing it. They were discarding it, even though they recognized, as I touched on earlier, the value of saving data in its native form in case it's useful, has value for some other project in the future. So they recognized that value, but the reason they weren't saving the data is that streaming events like this, especially at high speed, sometimes come in out of order. You have to just deal with that when you're doing real-time processing. But if you want to archive the data, you really don't want to save it in that kind of slightly corrupted form. There certainly are ways you can build to correct order before you store the data, but they take a lot of time and effort. And the concern for this particular institution is that by doing that, it might interrupt the effort or the performance of this core service, and that absolutely could not happen. That service had to run and return things according to a very strict SLA. And so they hadn't been saving the data, but they began to recognize it. They haven't finished building this, but they're looking at Flink now. With Flink's watermarks and checkpoints, this may be a situation where it's a simple thing for Flink to use Flink not for a bunch of processing, but simply to correct data in terms of correct order so that it can be archived. But if that works out for them by using Flink for this situation, now they suddenly come up with a valuable resource, an asset that they wouldn't have had otherwise. The other topic I want to touch on here in terms of the way things have changed is flexibility. And people have already touched on the idea of microservices. There are a number of different ways that a change in the way you work, a change in a particular technology that you use, more often a change in an architecture, can provide much more flexibility in the applications that you develop and the way they're used by organizations. And by flexibility can mean a lot of different things, especially multi-tenant systems. Can things really operate at the same time? Can you place applications wherever you want them? Can you start up applications in predictable environments and do that easily? Do you have a choice of the tools that you use, the tools that other people use to interact with the applications that you build? I want to focus just on this issue, though, of microservices, but specifically of stream-based microservices. More and more people are turning to streaming as the kind of centerpiece for building a microservices architecture. Now I'm not talking about stream processing. I'm talking about stream transport, event-by-event messages. It does matter a lot which transport technology you use if you're going to use that as the kind of lightweight connector between microservices. There are a number of different choices, but what matter is that the technologies that you use have to have certain capabilities. Now, right now, two that come to mind that have these capabilities are Apache Kafka, that really elegantly solve this problem, and MapR. MapR is a large-scale distributed storage data platform, but it has a built-in stream transport that uses the Kafka API. But in this aspect, both Kafka and MapR streams have the same two capabilities that are essential for using streaming as the heart of microservices. And that is, you need a system that even at extreme scale can persist data with high performance. You need persistence and performance. Some older transport systems, that was always a trade-off. You get one or the other. With Kafka-style transport, you get both, and that's what really makes the key difference. And why that makes such a huge difference, one of the reasons it makes a huge difference, is that this actually decouples the data sources, the producers, from the data consumers, and really isolates them from each other. And what that means, especially because in some cases this data is being used for very low latency applications, you need the messages to arrive for the consumer, be there essentially instantaneously, and these. But the cool thing is because you also have data persistence, even at that high performance, it means that a consumer doesn't have to be online, doesn't even have to be running in order to use the data. You can add consumers later. And that's how you begin to get that flexibility and that isolation and that support for multi-tenant systems. Now, this is not just theoretical. More and more companies are beginning to move large parts of their operations over to a stream-based architecture. It's obviously easier to build that up from scratch, but one of the nice things about flexible systems is that you don't have to move everything all at once. It's flexible even to go to this. This is a real-world example from a MapR user. This happens to be a very large transportation company. It just as easily could be a manufacturer. We see people with traditional retail doing similar things. But in this case, they're really embracing streaming microservices at a very widespread level across their company. This is just a super simplified diagram of one operation that they're doing to follow capacity, availability, and orders. But the way I've depicted it here, the horizontal cylinders represent the message streams. I've put those in gray so they stand out a little, because rather than just being the almost ignored connection between microservices, they're really the heart of the system. And so they take, in some ways, the role that kind of traditionally large databases have had, where multiple consumers are coming into a single database. Databases are certainly still being used. That's over on the right of this picture. But they're being used now as things that are optimized and specialized for particular parts of a large-scale project, whereas that kind of central source of truth, that kind of shared truth of data, these event streams are being handled by the stream transport. And in the case of this particular transportation company, this is an actual production system. But they decided they wanted to do some A/B testing. They had a new model, a new service that they wanted to deploy. And so they're actually testing that on production data in a production system and doing that safely because of this isolation. And as I said, this pattern can be applied to so many different situations. It gives you as developers, as application developers, huge freedom for what you test, what you build, and the kinds of systems, the situations in which you can build them. So more and more companies are turning to a stream-first or stream-based architecture. Again, if you go back to those examples and look at the use cases with that link for people, for example, using Flink for stream processing, you'll also find that a lot of them have built their systems with central streaming as the kind of structural background for the system. Now, a more specialized way that people can use streaming is in the case of MapR streams. MapR streams actually have bidirectional multi-master stream replication. So you can replicate a stream across geographical locations or from on-premises centers to cloud, cloud to cloud, and so forth. And what this means for developers, this is really cool. It's actually a separation of concerns between what developers think about and what people who handle system administration think about. You as developers shouldn't really have to worry about where data is located. You can do this very freely with stream replication. It just becomes invisible where the data is located. This can be a huge advantage. This goes back to the pattern I talked about earlier of finding technologies that you can leverage that handle aspects of your work natively, where you're having to build in the same thing application by application. This makes it much more efficient. An example here is, again, this is a real-world case. It's a very geographically distributed streaming service, but they needed to take their log events, their log metrics back to a central location for analysis. They were building in that data movement in all of the applications, which was a lot of work, very hard to do. They started leveraging stream replication to do that natively, and they said that within a short time, they felt like they had a year of development time in the bank. That's a nice situation. But it's that sense of being able to focus on the things that are key to the applications that you're building and letting the boring stuff be handled by a technology. Now, streaming is not the only way that you can get flexibility. There are so many excellent new technologies in the world of NoSQL databases. I'll just call your attention to a few that you can look into later. Kylogence, which is built on Apache Kylin, is a highly scalable OLAP system. ArongoDB has flexibility in the sense of having both graph, relational, and document as part of the system. MapR actually has a built-in NoSQL database. MapR DB JSON, this document style is particularly scalable. But the fourth bullet there is the one I want to call your attention to. This is not a database, but it is a highly scalable SQL engine. This is Apache Drill, which is an open source project. But the aspect of it that I want to remind you of is Drill is unusual, not only in being highly scalable, but it can discover schema on the fly. And what that means is it can be extremely useful for data exploration. Before you've committed to a certain project, to a certain optimization, to preparation for a certain database, which can take a long time, you can just reach in and see what's there in data. You can do exploration. And this actually can be done with almost no data prep. So this takes situations where you might have spent days or weeks or months in data prep before actually running a query. That means you've invested a lot in a particular query. This frees you up in just a few hours to build a query, ask the question, get a result. You can think about that, ask another question, and so forth, and this changes the rhythm of how you work. It lets people discover things in data that they wouldn't have been able to afford to look at before. Not only gets you to that query, you're still going to want to prepare data to optimize for a particular purpose, but this can be used in conjunction with other tools to really open up how you look at data, and people are finding that very useful. In terms of flexibility, certainly people working with containerized applications is a great way to have the flexibility of putting applications wherever you want in a defined environment. And people are doing that more and more, whether working on-premise or in cloud environment. But when you do that, keep in mind that you need a technology to orchestrate the applications and containers, the resources, and where they're placed. There are a number of different excellent technologies. I've mentioned on the slide Kubernetes, which is emerging as kind of an industry leader, but there are a number of different other ones from Mesosphere, Cloud Foundry, and so forth. But if you don't want to be limited to stateless applications when you use containers, you also need some sort of a data platform that will work in conjunction with these orchestration technologies so that you can persist data from those applications, from the stateful applications. On the slide I've shown MapR, which lets you do this as files, tables, or streams all in the same code base, all in the same system. But whatever system or multiple systems you use, you definitely want to, or I would think you want to, have a way to persist data. Otherwise, you're very limited in the applications that you can efficiently run in containers. Now, I've mentioned MapR, mentioned that it has files, tables, and streams all in the same code base. I want to point out that a number of MapR users are building their Java applications directly on MapR, and one of the things that they find convenient is because all of this is part of the same system, all part of the same code, it means they have a universal path name. And that can be a very convenient thing for developers as well. One more situation where developers should have the ability to work at large-scale systems across many different types of data and to simplify what they're doing, to have it be easier. Now, the last topic I wanted to touch on is how machine learning and AI, how they're changing, and the impact that they probably have or are about to have in your world. And one of the issues here is that when you're doing machine learning, I'm usually handling up huge scales of data, especially during the training phases where you're building training data to train a model. Those data sets tend to be much larger than what's used during normal running in production for a model. And preparing that data will come from a number of different sources. Especially at scale, you often use these tools that are built for big data, things like Apache Spark, Apache Hive, and often their output is in the form of HDFS, so you're going to store that data, and it's really convenient if you have a system such as MapR, where you can actually have the tools, the languages that you're going to use to interact with that data, be able to do that again directly and natively without having to copy all that information out. Now, which tools are the best tools to use for machine learning? Any ideas from the audience? Best tool for machine learning? A sneeze, okay. I've not seen that as a tool before, but it's possible. The fact is that we find people do tend to keep a tool set of favorite tools, but it's a very large tool set. Organizations that have big data science teams that are doing machine learning and AI successfully usually have somewhere between 5 and a dozen specialized machine learning tools that they're using regularly. And the reason they keep so many tools is that no single tool, well, I mean, part of it's personal preference. Everybody wants what they want, but it's not just that. No single tool fits every situation. Machine learning is very responsive to individual situations, to changes in the data, changes in environment. A tool that's appropriate at one period of time may not be the best tool as data and situation changes. So it's really good to have a number of different tools that you can use, and more importantly is to keep the option, the flexibility to add new tools as they show up. I changed my slides last night to include that little logo at the top, which is Stanford NLP, was actually released and announced last week. People are very excited about this. So on any given day, whatever you think are the favorite tools in your toolbox, there's something else coming down the line soon that you're going to want to use too. Now, notice that I've included Java and Python as these machine learning tools, and I'll get to that in a moment, why I think those are very important and should be part of that tool kit as well. But the big change that I want to mention to you in terms of what's happening with AI and machine learning, this may seem kind of odd because when the theme of the talk is to say what bits of the future are already here, what's already working. Well, machine learning and AI are in no way new. They've been around for years and used for years. But what has really changed? There really are changes, and it isn't just the hype. There is hype about AI in particular, but it doesn't mean there's not also value. So it's not just the hype that's changed, but what really has changed is that the breadth of adoption for these kinds of projects is going up very, very rapidly. And whereas previously they might have been done just by specialized teams, just a few organizations, they really are becoming mainstream. And so that's changing who within an organization is expected to be able to work with this system. It's changing how organizations look at the value they can get out of them. Part of the reason for the change is that the techniques have gotten better for working with data. These systems work best when you have large amounts of data, and again, the big data is just data now. A lot more people have access to large data sets, and a lot of the technologies have changed to make it much easier to work efficiently with them. But one of the biggest changes, and one of the things that I want you to keep in mind, is what makes a really successful, really efficient machine learning or AI system turns out not to be just the algorithm, the model, the people in the team who know how to build those models. It isn't actually the learning itself that is the thing that makes the biggest difference. Actually, 90% of the effort that goes into successful machine learning systems isn't the learning, it's actually the logistics. And that's, in some ways, I think, good news for everybody in the room, because to handle the logistics well, how you deal with data, how you extract and prepare it, how you prepare training data, how you archive training data, how do you deploy models, all of this has to be done, and done very well. And it has to be done very well in kind of similar ways across a huge range of different machine learning projects. So whether you have a very complicated algorithm, very sophisticated, or very simple algorithm, which, by the way, in some cases can be just as powerful as a complicated one, those things change. Those specialized machine learning tools that people want to use change almost by the day. But the skills, the basic software engineering skills, data engineering skills for handling the logistics of data and model management are pretty much the same across all of these projects. And they absolutely have to be done correctly, or these just become little kind of science fair projects in the corner. I love this article from Google that talks about this problem, the need for efficient data engineering and the handling of logistics, as saying with machine learning can act like a high-interest credit card for technical debt if you're not careful. And what they're really saying is, be sure you're looking at more than just that model and the algorithm. How do you handle the rest of the systems? Another change that we see is people are beginning to extend the concept of DevOps to something they're calling data ops, where they're really adding some of those data-heavy skills, data science and data engineering, to these teams, but keeping that same very successful approach of saying when you build cross-functional teams, you keep people focused on the same kinds of goals. They work more efficiently. They communicate more efficiently. It makes development go much better. I was very surprised in one of the books that we wrote last year called AI and Machine Learning in Production. We spoke with someone in the UK who has a consulting service that helps people take large-scale projects into production. And I asked him, because he works with so many different customers across different industries, I was curious about his experience. And I asked him what was the single thing that he felt was the biggest barrier to people getting into production successfully. And I thought he was going to mention some particular technology or data source. And what he said just immediately is, if people don't work with a DevOps style approach, it's much harder to get them into production. And that really took me by surprise, but you know, he's down there actually out in the field dealing with this every day, so that was good to know. I guess my last prediction, I'm not sure I should be predicting the future for you, but my last prediction is, I think very soon, if not now, you're going to see machine learning thought of as basically just a standard software engineering technique. And there really is a short walk from software engineering development to certainly data engineering and even to machine learning building the models themselves. There's not that huge gap that I think people have traditionally seen them in that way. So a quick review. These are the ideas I'm suggesting you keep in mind as the future has arrived now. Big data is just data. And look at the differences in the way people think about data, the value that can be in large-scale aggregate data. You can ask different questions, the importance of protecting raw data, the importance of recognizing that data may need to be treated in production long before code is finished. Also, treat yourselves to the pleasure of looking for technologies that can natively handle things that you're having to build in. If there are certain aspects of your work where you're building in the same thing across many different applications, look for ways that those can be pushed down to some technology that will handle them natively and transparently and save yourself that effort. There are a number of different technologies that we've touched on today, but it's not in any way limited to this list. The other thing to keep in mind is that streaming, and I don't just mean stream processing, but streaming as a heart of architecture is becoming much more widespread and maybe something that's really useful for you and your organization to work with. And keep in mind that machine learning and AI are becoming just an everyday part of life, and look at how that can best fit with the kind of work that you do. And so the real issue here is not for me to predict the future to you. In fact, all of you here in the room and the 809.99 million people that work with you, you're actually the people who are building the future. And so my question is, what future will you be building? These are some resources that you might enjoy, some free resources. Some of the material I've talked about today are included in these very short O'Reilly books. I've written 3 of those with Ted Dunning, who's somewhere here in the audience, and he's giving a talk here tomorrow. He's MapR's chief application architect. I wrote the one on Flink with Kostas Tumas, who's the CEO of Data Artisans. MapR buys the rights to make these available to you for free as a free download, and the links will be there. You'll have the slides. There's also this book by Carol McDonald for people who are kind of getting started and want to improve their skills with Spark. A last reminder is please continue to help support women in technology. This isn't just good for women, it's good for society. And as one woman in high tech, I say thank you very much for having me here today.
Thank you very much. So you can say, I have one question for you.
Oh, dear, okay.
So we will talk a little bit about the future. And,
okay.
It said that machine learning and AI is supposed to take many jobs in the industry, right? So I mean, from accountants and a lot of the. So what do you think about that for developers? So when will there be AI machine learning that actually writes the codes for the programs?
I'm not enough of an expert, and there are other people in the audience who would give you a better answer. Having said that, that's my disclaimer. I'll give you my answer anyway. I'm sure this is coming if it's not already being done. But I think it becomes a minor thing. And in the same way, I'll just give you the analogy. AI is certainly, in robotics, are having a huge impact, say, on the way manufacturing is done. And for any given job, for a person who's on a manufacturing line, they say, well, will my job be replaced by a machine? Yes, it may be. That's a reality. But at every moment that happens, some new job is created for people who build that system. Or I'll give you an example. I have some association with the University of Sheffield in Northern England. I've been interested. There's a UK government initiative called the, I'm not good at acronyms, the Advanced Manufacturing Research Center. And they're really putting together a number of large industries, about 200 industries. I think Boeing is the one that's contributed the most, so their name gets slapped on there. But they work directly with the university. There's a huge sort of 9-building campus to change the way manufacturing is done, put the kind of advances at university directly in contact with industry. And one of the things that they're doing is looking at how data, smart tools, AI-driven systems can be used directly on a manufacturing floor, and how to make that much more flexible, where you can reconfigure manufacturing as you quickly need to change as advances are done. So it's a very long background for the answer. But I think the cleverest thing that they've done in this system is they've also opened up a training school as part of that for, I don't know, a couple of hundred apprentices. Because the fact is, as they build these new systems for working with, say, smart tools and smart manufacturing, who's going to do it? I mean, who knows how to do it? And the people who are being trained, who would have gone to a traditional technical school to be trained, maybe to work in a machining shop or something like that, are now being trained on these new systems. And there literally is a waiting list for people to hire them. There's a waiting list for new people coming into the program, but companies are just waiting to hire them. So back to your question about programming, I assume it will be done. I think I'm old-fashioned in that, I don't know. I think humans make better developers than machines do as developers, but I'm willing to be proven wrong in the future.
Okay.
Great. Thank you.